All right, today we're going to be taking some notes on quadrilaterals, which is the first unit of our geometry, our first lesson of the geometry unit. So first we're just going to go over some vocabulary and symbols that we're going to be using throughout the lesson. First, let's talk about right angles. A lot of us know this from elementary school. Right angles have exactly 90 degrees. So go ahead and fill in that blank. So that means that that angle has to be a perfect corner, 90 degrees. You can't have something too little, and you can't have something too big. So I'm going to go ahead and X those out. Those are non-examples. The symbol that we use for 90 degrees is a little corner inside that angle. So it looks like a little square. So anytime you see that symbol, that's a clue that that angle has exactly 90 degrees. Next up is congruent. Now, we learned about congruent when we were talking about proportions. Remember, anything that is congruent has an equal length. So, for example, if you have two line segments and they are both labeled 2 centimeters, those line segments would be congruent. A symbol that we use to show that two lines are congruent are little tally marks. So for example, if I want to say that those two lines that I just drew are congruent, I'm going to put a little mark in the middle of both of them. And if they have the same number of marks, then that means that they're congruent. So these other lines that I'm drawing, if I want to show that they are congruent, I could use 2 tally marks. And that means that they are congruent to each other, but not the same as the ones with just 1 tally. All right, our last vocabulary word is parallel. If 2 lines are parallel, that means that they will never cross. So that just means that they're going to be going in exactly the same direction. And even if you kept those lines going, they would never ever cross or run into each other. So if I had 2 lines that cross, that would not work for parallel because those 2 lines meet. The symbol that we use for parallel, we have those 2 lines, and then we use a little, it almost looks like an arrow going through it. And just like the congruent, if they have the same number of arrows, then that means that they are parallel to each other. So these ones, even though they would definitely run into those other ones, if I put 2 little arrows, that means that those 2 are parallel to each other. All right, so now that we've gone through our vocabulary, we're going to move down to the names of our different quadrilaterals. So first up on our quadrilaterals is simply a quadrilateral. A quadrilateral is the word that we use for a shape that is 4 sides and is a closed figure. So some examples that I want to put in this drawing column. Even if it's a weird shape, if it has 4 sides and it's closed, it works. Then we have our more normal looking shapes that we run into a lot more often. The only time that a 4-sided figure is not a quadrilateral is if it doesn't connect. It's not closed, like the letter M. That has 4 sides, but because those 2 sides don't meet, that one does not work. All right, next up is our trapezoid. I like to call the trapezoid the weird cousin. So I'm going to write that little note here, and I'll tell you why it's the weird cousin in just a second. So a trapezoid is a quadrilateral. It still has 4 sides and is a closed figure. And it has 1 set of parallel sides. So some examples of a parallelogram, a trapezoid. This is more common that we end up seeing that. And you can see that, let me start that one over. And you can see that this line and this line are parallel, whereas these other 2 definitely would run into each other. Another example of a parallelogram looks like that. And it still has exactly one set of parallel sides, so it still counts. My next shape that I'm going to talk about is the parallelogram. A parallelogram is also a quadrilateral, but unlike the trapezoid, and this is why that trapezoid is the weird cousin, it has two sets of parallel and congruent sides. So a lot of times I like to talk about this parallelogram almost like one of those pink pearl erasers. That's what that shape makes me think of. So it has, there's one set of parallel sides. There's the second set. And you can see that I'm using those symbols because the ones that have the same number of arrows are the ones that are parallel to each other. I'm just going to draw another example. So both of those are examples of parallelograms. Next up is our rectangle, and a lot of us are familiar with rectangles. A rectangle is a special type of parallelogram. So when I say it's a special type of parallelogram, that means that it both has that two sets of parallel and congruent sides, and it's a quadrilateral, so it's a more specific type. The thing that makes a rectangle special is that it has 4 right angles. And a lot of us know what a rectangle looks like, but we're going to make sure that we have those symbols. So I'm going to go ahead and draw my rectangle. It has 2 sets of congruent and parallel sides. So you can see that I've got 2 different sets of congruent sides. And then I'm going to show those right angles using that little box symbol. So that's an example of a rectangle drawing. All right, so now we're going to talk about the rhombus. A rhombus is a different kind of parallelogram. And this one has 4 congruent sides. So a lot of times when people are looking for a rhombus, we say that it's almost like a square that got squished. So there's an example of a rhombus, and you can see that I've got 4 congruent sides there. And because it's a parallelogram, I still have 2 sets of parallel and congruent sides, and it still is a 4-sided closed figure because it's a quadrilateral. All right, I'm going to have to move my sheet down just a little bit, so make sure that you have what I have so far. All right, looking at the square, this is the most specific type of quadrilateral that we talk about. It is also a type of parallelogram, but it is related to the rectangle because it has 4 right angles, just like the rectangle does. But it also has 4 congruent sides, just like the rhombus. So a square's picture gets really detailed. You got to make sure that it has 4 equal sides and that it has 4 right angles. And it can be a big square, it can be a little square. Just make sure that you have those symbols. And that one gets really small. All right, so now that we've talked about all of our different quadrilaterals, we're going to kind of see how they're related and learn about that, how I call the trapezoid that weird cousin, in our maps. So at the very bottom of your sheet, we've got 2 different maps that we use to help us show how these quadrilaterals are related. So let's start with this one on the left. You can see the quadrilaterals already filled in. Remember, these are all different types of quadrilaterals, so it's at the top of my family tree. Now, based on how many parallel sides it has, can help us narrow it down. So remember, a trapezoid has only 1 set of parallel sides, and that's why it's the weird cousin. See how that family tree branch just stops right there? The trapezoid is the one that's all on its own. On the other side, if it has 2 sets of parallel sides, we call it a parallelogram. And then we can even get even more specific on those parallelograms as we move further down the family tree. So if it has 4 right angles, it is called a rectangle. And if it has 4 congruent sides, it's a rhombus. And then we have that super specific last one that we talked about, the square, which is pretty much if you took a rectangle and a rhombus and put all those qualities together. So the reason that I like this map is because it really helps us with our always, sometimes, never questions. So anytime you see a question that has to do with always, sometimes, or never, or having to fill in those blanks, this is a really good tool to help you use it. So moving down our family tree is sometimes, moving up is always, and moving sideways on our family tree is never. So I'll give you an example using those words and how it shows on our little family tree. So if they're asking me how many times a quadrilateral is a parallelogram, I move down the family tree. So that's sometimes because I moved down. But if they ask me how many times a parallelogram is a quadrilateral, that's going backwards. So I'm going up the family tree. So that would be always. And we'll have a lot of time that we can practice using that little trick in just a moment. All right, our other quadrilateral map. This is kind of like a Venn diagram because we have some circles that overlap. But they're all part of this really, really big square. So this really big square here is our quadrilateral. So remember, quadrilaterals are anything that has 4 sides and is a closed figure. This weird circle off to the side is our trapezoid, and I'm going to go ahead and shorten this just for the sake of space. So our trapezoid is the one that's not really related to anybody other than the quadrilateral. Now this really big, almost oval circle here is our parallelogram. And then we can break it down to rectangles and rhombuses. And then this little overlapping space is our square. So this is just another way that we can show how those quadrilaterals are connected. So if the circle is completely enclosed in the bigger shape, so for example, because that rectangle circle is found inside the parallelogram circle, I know that a rectangle is also a parallelogram. I also know that all of these shapes are quadrilaterals because they're all in that really big square. So these are just some visual aids that we can use to help us kind of understand how our quadrilaterals are related to each other. So now we're going to go ahead and get started on some practice. We're going to start out with some IXL. So if you go ahead and go on to IXL on 7W5. Again, that's 7W5. You're going to get some time to practice how these are all related and being able to pick out which ones are which.